So, hello everybody. Welcome to another meetup number 8. We have a big program for tonight. Let me add my presentation. Um, yeah, we have lots of fun things planned. So, meetup number 8. Welcome, General. Hello. As always, the slides and video will end up on our website, hackthewereld.nl. So, in case you want to download it or view it later, you can always use that to get there. There's a bunch of announcements. I talked to Hack the Box this afternoon. And they asked, well, do you want to share it with the group just to make sure that everybody knows? So here we go. First one, hacking Battleground. We've talked about it in the Discord quite a lot. They launched it, and it is quite fun. We've had several people playing several games already. So if you want to try it out, be sure to ask in the Discord. There's always people that want to play the game. The other one is Hack the Box Academy. It is not as well advertised by Hack the Box yet, but it is a very good resource to learn about various topics, from using Nmap to using Active Directory. It's a great resource to try and hone your skills. So if you want to learn something, check them out. Then we have some other announcement, and for that I'm going to first talk about something I'm making, and then we'll add Daniel to the discussion. I thought about launching a project, and I did. I launched Advent of CTF, which is a CTF game for December. For every day in December, there's another CTF challenge. So in a little bit over a week, we will have the first challenge being launched on December 1st, 8 a.m. Central European time. And there will be 24 unique challenges, because then it will be Christmas and everybody will have something else to do. A designer colleague of mine, he got really excited and he created 24 cyberpunk themed badges that we can share on social media. So if you like playing CTFs and want to have something to do at 8 a.m., feel free to check it out. There will be a registration site going up just before the December month. So you can add yourself to the scoreboard. But you can get points and play games. So, and then there is another nice little announcement. I'm going to add Daniel. Hello, Daniel.
Yes, hi everyone. As some of you may have noticed in the announcement section, a couple of weeks ago we asked about if any of you would be interested in competing in coding challenges. And since there was a lot of positive feedback on that, we made a Discord bot that some of you all have already seen. There will be 2 new channels added, and you will be able to interact with the bot mainly through DMs, and you can actually reach it right now. If you send a help command, you will see the list of commands that are available to you. For example, you can submit ideas for topics for upcoming challenges. If a challenge is live, there's a way to submit your code through a zip file or a link to the download. You will be able to vote through the direct message with the bot, and everything will be automated. So, for example, in a couple of weeks, we'll do a few hours. It will pick a random topic from the ones that are selected to be actually done, and then you will have like 4 or 5 hours to make the project, submit your code. Then all the submissions will be published in one of the bot channels, and after a few hours of voting, the bot will announce the winner. So it's mainly community driven. We have some ideas already that are already accepted, But feel free to just submit anything, and then we'll take a look at it periodically, and the list will grow and grow. So if there are enough topics, we can do it more often. If there are not a lot of topics, then we'll do it semi-regularly. So it also kind of depends on how much the community is willing to spend on time and that. So I think that's everything I wanted to say for that.
Very cool. Very cool. All right. Then thank you for joining and announcing it. It will be a quite new, nice thing to do on the Discord. So thanks.
Yeah, and if you have any questions regarding the challenges or the bot itself, just shoot me a DM.
Sure. Sure. Very cool. Thank you very much.
All right.
Let's see. I'm going to remove you, Daniel. See you on Discord.
Yes.
Oh, well, I'm guessing he would say, sure, thanks, see you later. So, nice new feature on Discord for the people that like to compete. What to expect today? Well, the first thing we'll have a presentation by Alex. He will talk about binary exploitation. Then we'll actually, around 7ish, have a small break. We'll play a game, and you can win some prizes, some really neat prizes. And then we'll continue with the workshop part by Alex, and then we'll close. We had somebody who wanted to read Miffy to us to close the meetup, but he had to cancel at the last moment. So if we have any volunteers, feel free to let us know. The next meetup will be quite fun as well. It will be our Christmas theme meetup. It will be December 16th. And Egress, you might know him, Ian, he presented, I think, a couple of meetups ago, 3 or 4 meetups ago, about content making within Hack the Box. And I convinced him, I asked him very nicely, to show us some of his work in the form of an active machine on December 16th, and he'll guide us through the active machine, and then we'll post a video about that machine after it has been retired. But that will mean that you have a chance to gather some points on a machine that you might not have done yet. So that will be quite nice. So that's our next meetup, December 16th. And as we talked about in Discord, the time we currently have 6 to 9 p.m. We might make it 7 to 10 p.m. We'll see. But for today, we have Alex. I'm going to add him to the stream. Hello, Alex.
Hey guys.
So yeah, it's all you this meetup.
Can I start sharing?
Yeah, you can share your screen or share your window.
Okay. Is it visible?
Let's see. Yeah, there we go.
Okay, great.
Let's see what you share. Yeah, there we go. I'm going to remove myself from the stream, and it's all you. So feel free to take it away.
Great. So I was thinking today to present how to write assembly, but for that we really need to know a couple of things. And after that, I would like to present to you guys how to write shellcode. So that would be malicious assembly that in some cases would allow us to elevate privileges or to execute remote code. And to showcase that, I will showcase a basic vulnerability, the most basic, actually, from binary exploitation, which is a buffer overflow. No protections whatsoever, so it will be very easy to exploit. We will see it in the workshop. And yeah, let's start understanding what is assembly. So what is assembly? Well, what assembly is a quite low-level language, actually the lowest level above binary code, so machine code. today we will learn about the 64-bit version of x86 assembly. Just know that on other processors, there are other types of other versions of assembly. Assembly is a big sort of a big class which contains a lot of different types. But today we will just talk about the x86 version. We will be using Linux-based OS, which is Kali Linux, and we will be learning about the Intel notation of assembly, which, in my opinion, is way more readable, and you will understand it way quicker than the AT&T version. Just know that the AT&T version is used mostly in academic circles and on Linux on Linux systems, but it's basically an interpretation of the same thing. So assembly, as I said, it's a low-level programming language, and for now you should think of it as a direct translation of machine code, which is almost correct, but with some edge cases, which they are not important for our talk, but just think of it as a direct translation into machine code. And as I said, it's processor specific. So ARM processors have a different assembly language. So if you try to assemble x86 on ARM, it won't work. And okay, let's go into how a program looks in memory. This is somewhat a required step to know in order to understand further. So, how does a program look in memory? Well, we can see here on the right a small diagram of a program. We can see here the user space and the kernel space. We don't really need to know how they work. We are mostly concerned with the user space because programs, most computer programs live in the user space. So when you just write a program, your program will almost surely have a text section, a data section, a BSS section. If you are using dynamic memory, it will have a heap section, and of course, it will have a stack. Now, these are more, you can think of them more like conventions. So, while, yeah, indeed, program has a text section which has the permissions of the memory. There are read and execute. So you can read what instructions will be executed, and you can of course execute them. So that is where your actual code resides, and the data section is used for you can think of it as the place where constant variables from C, for example, are found, and this section is has only the read permission, and the last section is BSS, which has read and write, and this section is the place where uninitialized variables are usually stored. Now, you might think, well, couldn't data be stored in the text section? And if you think that, yeah, it could, like some compilers do that, and in my opinion, it shouldn't be done. But as far as you are concerned, most compilers respect this respect these conventions. So you won't see compilers that don't respect them, probably. Well, I talked a little bit about, I mentioned a little bit about the instructions, but what is an instruction? So an instruction is just a statement that is executed at runtime. So the instruction has multiple elements, of which the label, we will talk about all the elements further, but you just have to know that it has a label which is optional. So an instruction, which of course needs to be there, on some operands, which are the arguments to the instruction, and a comment. But besides, only the instruction is required. So as an example, we have here an add instruction, and we see here that it has 2 operands. So it has an RIX and RBX, and you might wonder what are these? These are registers. I will explain what they mean a little bit further, but just to think of them that they are just like variables. And you can see here that this instruction doesn't have a label, doesn't have a comment, just is just the symbol of the instruction and the operands, and you might guess what it does. It just adds RBX to RIX, and that's about it. And okay, let's divide how an instruction statement looks, and we'll talk first about the labels. So what are labels? Labels are just, you can think of them as a symbol placed at the beginning of the instruction, so that when your linker figures out the addresses to link to, for example, for a function call, it knows where to go. So like when you say when you say about the label, you just assign the current value of the active location counter to it. But what does that actually mean is that all the instructions will be executed sequentially, and when it gets to a label, it just replaces, it just makes a note of it, makes a note of where it found it, and further down in your code, when some other code references that label, it will just say, well, okay, I saw this before, I know where is the address, I can just replace the address with the label. And as such, we as programmers, we don't have to remember the addresses, we just have to put a label there, and we are good to go. And the thing is, it must be defined only once, so you can't have multiple labels with the same name. And what you really need to know, or the only label you should know, is the start label, because that is the entry point to your code. On Linux is the start label. On OS X is the main label. It's called main. It's just the same thing as the entry point to your code. You will see further down how it's used. And yeah, let's talk a little bit about operands too. So operands are, as I said, arguments to the instruction. So there are some special cases. For example, the one in which an instruction has 2 operands, and on Intel, the first operand is the destination operand, and the second operand is the source operand. What does this mean? Is that the first operand is the operand that is acted upon, and the second operand is the operand that usually has something to do on how it's acted on the first. So like, let's take the example with the add, right? So in the example we had like add RBX, RIX, or something like that. That means that RBX is the operand that is acted upon, right? And RIX has something to do with it, right? Because you add RIX to RBX. So in that case, and in the cases in which it has two operands, it acts upon it. But like you will see further down that, for example, move instructions, you just take the value from the second operand and you put it in the first. So this is how instructions with two operands work. But there are some instructions that have implicit operands, like jump not zero is that it's what it stands for. And the thing is that the jump not zero has only one operand, which is the location. And like if you just saw it, it would make no sense, because jump not zero implies that something needs to be not zero. But usually, and in most cases, the jump not zero, it's used after a compare instruction or a test instruction. So you are testing for something to be not zero, and if it is, you jump to the to that address. So it's a conditional statement that you will see further down, but yeah, it just has an implicit operand, and there are three types of operands. There is an immediate, which you can think of it as a constant. There is a register, which you can think of it as a variable, and there is just a memory operand, which if you are familiar with languages who manipulate memory directly, for example C, you already know what it means, but it just references a place in memory, and yeah, that's about it. So what are registers? Well, registers are actually memory locations inside the CPU. What this means is that they are a lot more fast to access than if you would access it in RAM. So they are used for optimization purposes. And when you get to work with registers, you will mostly use these registers on the right. So I will explain what they are used for, but before, you should know that you can access these registers in multiple ways. So if you want to access the 64-bit accumulator register, you will say access era X, and you can do this for 32-bit, 16-bit, and 8-bit. Some registers don't have this option, but the ones that you will be working for fortunately do. You see here that what the name means. So RX is the accumulator register, RBX is the base register. Actually, all the names here are just have a historical meaning. Most don't signify anything today. The important ones are the RCX, which has kept the meaning. So you might, it's a counter register. They can all be used for whatever purpose you want. It's just that compilers usually use them for some specific purposes. So like RCX, you might see it in a for loop, and RIX, you usually see it when you return the result from a function, but that's just because of the calling convention that you will see later on. RSI and RDI are usually used for memory operations like string, like copying strings and so on. So these registers, most of them haven't kept their meaning, but some of them are still used for what they were intending to. Just know that you can use them for whatever you want. So, okay, that were the general purpose, but what you should be aware on is that there is a flags register. The thing with the flags register is that it provides no direct access. It just has all these fields with flags that are just bits that are set in some cases. So like you have here the ZF, which is not represented here unfortunately, but the ZF is the 0 flag, which is set in case of test or comparisons. The carry flag, which is set in case of arithmetic operations, and you can't access it directly, but just know that this is the register that makes the decisions in cases like jumps and a couple of other instructions. You have the instruction pointer, which is very important to know, which contains the address of the next instruction to be executed. So remember when I told you that how code is executed sequentially, this keeps track of what is executed, and it can only be modified through the stack, and we will see how. And there are a couple of other registers which you might get to know further down in your binary exploitation path, but right now I just included them for completeness. And the memory register, as I said, provides memory access. So this is the full syntax of it. You most commonly just see the base, right? So you might see a 64-bit register, but for completeness, just know that you can it can be used like this. Mostly you don't see like this, but in some cases, like iterating over some structures, it's very useful. But going forward, something way more important is the NDNS. So what this means is how the order of bytes is stored in memory. So let's say you want to push this constant to the stack, right? In Little Indian, as you can see here, you will get the least significant byte stored first in memory, and the last significant byte stored last, the most. But this is a very important concept to know when you are writing shellcode, because if you try to make a string in memory dynamically, you really need to know how what you are pushing gets on the stack. So I will explain the stack in a little bit. There are some common instructions, like for example, for data transfer, you can transfer the value from the source operand to the destination operand. The push and the pop, which are stack operations, we will see them in a bit. If you are familiar with computer science concepts of data structures, you are already aware of the stack data structure. But if you are not, I will just explain it a little bit. Exchange just exchanges the values from the two operands, and LEA is load effective address, which just loads the address of SRC in the destination. This is commonly used for cheaper arithmetic operations, and by cheap I mean the memory is less in the case of shellcode. Arithmetic instructions are, as you can see, just adds the value to the destination, subtracts the value from the destination, increases and decreases register. And there are a couple of logical instructions, the AND, the OR, and XOR, which you can see right here, their purpose. The thing with this is that these are the instructions that you will use when you will write shellcode. Don't bother if you don't remember all of them or any of them. Like, it's not that important. Just there are quite easy to remember, and just you will get to remember them as you use them. So the ones that you will commonly use them are probably these ones, and you will get to remember them, but don't bother about it. Like, you won't remember them in this much amount of time. Just be aware that they exist. So the other instructions that you might need are the control flow, which is the test and the compare instruction. These are instructions that, for example, the compare subtracts makes a subtraction from arg0 to arg1 and sets some flags. So let's say you compare two numbers, right? So if they are the same number, the zero flag will be set, because that indicates that is the same thing. And if you have a jump equal or a jump 0, that would only be taken if the two arguments are the same, right? And the test is commonly used to check if an operand is 0 or not, and it's usually used with the same argument in both sides. And just know that it can be used like in the same manner as the compare. So you have here the jump to a location, the GCC with which is a conditional jump. I talked a little bit about the jump not 0. So there are a couple of other jumps, like jump greater than or jump lower than, or this just vary on what you need. But there is the call instruction, which is a jump, but also pushes the instruction pointer onto the stack, so the return will know where to continue execution from. And you can give it an argument, which is the value that it can cut off the stack before it gets to the return pointer. And there is the syscall, which it does a kernel switch and executes and with you can execute code in the kernel. This you might think, okay, well, I can execute code in the kernel. Well, of course you can't execute your code, but you might get to. But you most commonly you execute some specific code put out by the operating system, some helper functions, which you will see a little bit further on. And others are just the load effective address, which is I personally use it mostly for arithmetic operations rather than what's its purpose, and no operation. This is commonly used as a padding, because if you are unsure where your return address will hit, you can just fill a place in memory with a lot of knobs, and you will be pretty certain that if you cover enough memory, your execution will hit. And right now, let's talk a little bit about the calling convention that is used on Linux and on the 64-bit version. The ERA-X register is used to return a value from the function back to the caller. So if you remember from C, you can just return something from your function. This is done through RIX. RDI, RSI, RDX, RCX, and R8 and R9 are used for arguments to a function. It's important to know that in this order. So the first argument to the function will be RDI, the second will be RSI, and so on. And if you use more than this, it will the stack will be used. And the RSP and the RBP registers are used to track the stack. You will see in a little bit how that works. So okay, let's see how exactly the RSP and the RBP worked. So remember when I talked about the sections of a program and the stack? Well, this is how the stack usually looks in memory. So this is the stack frame of a function. The stack frame, just imagine it as a place in memory which is temporary, and it's designated for the functions, local variables, and the return address and the save frame pointer to reside it. And there are a couple of more things, like for example the adjustment, the memory adjustment that is set by the compiler, but that is not important for us right now. It's just that for the stack there are a couple of operations like push and pop. So the push instruction just decrements RSP, then stores the argument on the top of the stack, and pop just is the opposite of push, so it stores the value from the top of the stack into the argument and increments the RSP. But what's interesting is that call, as I said, pushes the instruction pointer onto the stack and sets it to the value of the argument. So when you say call function, right, it just pushes the instruction pointer and changes execution to that function. But what we will be using is the ret, right? Because at every function return there should be a ret, and this pops the instruction pointer of the stack. And in the case of a buffer overflow, well, we can get to overwrite that return address pointer, and this would be great news to us, because if we get to do that, we can change execution of the program to something that hopefully we control. So in this case, we can see the simple buffer overflow example. So this has two functions, and it gets the one argument from the command line, and it calls foo with it. And you can see here that its string copy is a notorious function for buffer overflows. It does no check of length whatsoever, and you can see here that the buffer, the C buffer, is has a limited size. So what would happen if you get to override that buffer is that you would first fill up the stack frame, and at the end of the stack frame you would get to fill out the saved stack frame pointer. And after that, the behavior that we are interested in is that you will get to overwrite the return address. So this is what we really need. If we get to override the return address, we might get it to to change the execution of the program to another place in memory. So remember that in this case, we control the stack. We control what's on the stack. And if the permissions on the memory allow us, so if the stack is executable, we know the address of the stack, we can just return back to the stack. And since we control the stack, we can just put our malicious code there and execute our code. So we will see this in the workshop and how it works. But yeah, this is a very interesting concept. And unfortunately, a long time ago they figured this out and they disabled the executable stack. But of course, there are a lot of bypasses. And a couple of more things that you should know are syscalls. So how they work? So a syscall just invokes an OS system call handler at the privilege level 0, so in the kernel. Modern OSs don't use the level 1 and the level 2. So Linux, Windows, they just use level 3 for user mode and level 0 for the operating system, so for the kernel. So it just switches the context to the kernel and executes some kernel code. And we will make use of the system calls later. You can actually find the tables of all the system calls if you go to Google right now and search for x64 Linux system calls. You will get the whole table of them, and you will get to use them in writing the shellcode. And it's the AMD 64 calling convention. It's used here too. One additional thing is that RAX is used to contain the number of the system call. So in the table, you will see the number of the system call on the left, and you can call any system call from there just by passing the number and the arguments to this instruction. And just a quick introduction to NASM is how you should use it. So when we'll get to write the shellcode in a second, you will find out that you will structure your code just like this. So remember the start. So the start label is your entry point to the code. And one more thing that you should do is make this global. So the assembler knows where to go, right? And another directive here is the section.text. This just starts the section. If you remember from the section slide, this is the text section. So your code goes here, and to assemble the code, you just use the NetWide assembler, and you will use the ELF64 format and on the shellcode, and you will link it just like this. And after that, you can dump the contents, so the shellcode that you wrote with this command. So I am not sure if I have enough time. These are for the workshop. I can go on and present them. Arjun, is that okay?
Well, we have some time. Yeah. Do
Yeah.
you want to have it during the workshop, or do you want to talk through it now?
Well, it's sort of a little prerequisite of the workshop is the shellcode.
Sure.
But yeah, I can introduce it, and in the workshop we will get to see how it's used, right?
All right. Very good.
Okay, great. And so we actually get to do something fun. We get to write a shellcode. So how do we use what we have learned to write the shellcode? So on on the right here, we see the what our shellcode, what we would like our shellcode to do, right? So we would like to execute bin.sh. And this would be useful in case of privilege escalation, right? So you would do that in case of you would do that. So first you would want to assemble the string on the stack. So what you see here, the first argument, you want to put it together. But since your code should be position independent, you can't really define it as a place in memory, because on the victim program you won't have that place in memory. You will have to build it yourself. So in this case, I just use the ERA-X register for my place where I will build up the bin.sh. And as you see here, I'm pushing it in the correct order so that on the stack it will be assembled as bin.sh. So I take account of the MDNS to push the correct string. I then push the RSP register into RDI. RSP is modifying itself every time you push or pop something from the stack. So it keeps track of the top of the stack, right? So right now our string is at the top of the stack, and we want to use it as an argument to the exec v. So we put it in RDI, and then we just XOR ERA-X, and we put in AL 59, and 59 is the syscall number of exec v. So if you looked at the table, you saw this, and it just assembles the other arguments. You can see here there is a little bit of a difference here, because in C this would work, in assembly it doesn't. So it it pushes RSI and RDI on the stack, and it moves the stack pointer to RSI. This is the second argument. In this case is null, in this case is not. It's actually making an array of bin.sh and null. This is required to execute it. So you can see right here what it actually does, right? So this is the basic shellcode. But what if we want to do a remote attack, right? So we would want a reverse shellcode. So it's still the same thing. So it's still the basic shellcode. You can see it right here, but we have to take a couple of steps. And these steps are we want to make a socket, right? So you want to make a TCP socket to your IP address. In this case, it's making it to localhost, because you would be testing on your own machine, but of course you can do it remotely too. What I did here, I used 127.111 because I was trying to avoid not to have any zeros in the shellcode. Having zeros in the shellcode would break attacks like string copy, because strings are terminated by a zero. So if I was using this shellcode in an attack that was using string copy, it would cut my shellcode, so I wouldn't be able to perform the attack. And how is this done? So we want first to set up a socket. This is done pretty easily with the syssocket syscall. So we just, as you can see, it's pretty similar. So you just XOR out RIX, you put the required syscall number, you XOR out RDI, you put the argument, and so on and so forth. So it's pretty similar to the code in C. And what do we do next is we get to build the sock addr in structure, and we do this by executing move RIX RBX, and we are then storing the RIX. We are moving it into RBX because we want to save what the C socket returned to us. So we want to save the socket, right? And we are putting the 42 in the AL, right? We are then moving RBX into RDI. So we try to save it into other places, and we are storing RDX and pushing RDX. We are basically doing this. We are setting the scene 0 to 0. We are then pushing the IP address on the stack, right? So what you can see here is we are gradually building up the scene structure in memory with assembly, and we then put a port, and in memory a little mention that this port is in network order, so sort of in reverse. If you play around a little bit with the ht-on-s function, you will notice this behavior. And we then just set the scene family to AF inet, and then we just put the correct arguments, and we call sysconnect, and then we just do a for loop. So remember the RCX, how I said it's a counter register. Well, I got to use it as a counter register right here. So we are just making the std in, std out, and std error go to the socket. So everything that will be, let's say, printed to std out, it will go to our socket instead, right? So this is what we are doing with dup2, right? And we are just iterating through from 0 to 2, and these are the numbers of std in, std out, and std error, right? And this is basically it. So after we do that, you can see that we execute the bin sh, and yeah, then we get the reverse shell, and that's pretty much it. And these are the references for you guys to, if you want to read more about assembly. And if you have any questions, feel free to ask. I'm not sure how I can view them.
Well, there's currently no questions on the YouTube. On Discord, however, there's quite an active discussion going on.
Yeah.
With screenshots of your presentation.
Sure.
And let's see. So the first one was by Kite that we already answered because there was a XOR RSI in your presentation, followed directly with a push of RSI. So we explained that it sets to 0 and then it actually pushes a 0 to the stack.
Okay.
Yeah, but then there's another one also by Kite. It's,
where can I see it?
It's on Discord in the Meetup text channel.
Okay.
So we have the Meetup voice and just the.
Yeah. I'm trying to scroll to it right now. Who has the question?
Yeah, so it's Kite. Let's see if I can.
Kite. Okay.
So there's a XOR RDI, and then a move DI 0x0 to FF.
Okay.
So, she was wondering, she said, this person, I don't know if it's a man or a woman. So Day.
Let me-
That's the correct one.
Let me
Can
go
you
into-
explain that?
let me go into my presentation to find this is it.
So XOR RDI, and then push of a move DI 0x02 FF.
Okay, so I think this is with the reverse shell, right? Well, what I did here, well, I needed 2FF0, right? Well, no, I needed a 2, but I can't really make a 2 because that would mean I have a 0, right? So I said, well, what can I do? Well, I put 2FF into DI, right? And then
Yeah.
I just shifted it to the right. So when I shifted to the right, RDI was empty before. Now it just has our value, 2FF. And when I shifted to the right, I just a 2 is left in there. So I did this technique twice. So you can see it further down. It will just one it will be left in there.
Yeah.
So this is pretty much it. What one thing that you should you guys should know is that in the case of DI, the rest of the register is not changed. But let's say if here would be EDI instead of DI, this would make the whole register to the value of EIX. So the higher end of the register would just be zeroed out.
Okay.
I hope I made it a little bit more clear.
Yeah, well, let's see. I'm sure Kite, among many others, they have
Oh, yeah,
questions
yeah.
about that. So we will continue that in the Discord, I think.
Yeah, I'll just look at the meetup text.
Yeah. Thank you for this presentation.
Yeah, for sure.
I already said in the chat it's a little bit more technical than the general presentations that we do in.
Yeah, I really try to cover it all, but there is a lot to talk about, and 1 hour, of course, is not enough to cover the whole assembly.
No. Within the university, we have courses that last for weeks.
Yeah.
So,
Right.
but I think the nice thing is that you have prepared some workshop files for our
Oh,
members.
yeah.
We will put links, or you will put links in the chat, and we will pin the messages.
Yeah. So after the gifts will be given out after I think it will be a quiz or something.
Yeah, we will have a quiz indeed, and that will lead to goodies. So that's always a very
After that, I will release the workshop, and we will go through it.
Very good. Very cool.
So,
there's at least several people that are very actively trying to understand what's going on.
Yep.
So I think you will be
stop sharing,
bombarded with questions.
I stopped sharing, but I will answer the questions right now if that's okay. I think we can go to the quiz, and I will this time answer the questions.
Indeed, very good, cool. I will remove you from the stream, and then it will just be my face. So thank you very much, and see you in the Discord.
Yeah, for sure.
So that was quite awesome. We learned a lot about shellcode, about assembly. There will be a workshop after this. But first we thought just having the presentation, all the materials, might call for having a small change of scenery, just to let it all sink in. And we have some gifts to give away, but we don't have enough gifts for everybody. So we thought, how can we do this? And we figured we would do a quiz. So we only have 10 questions. 10 questions. Not very long quiz, but it should be good fun. I'm going to start up the Kahoot thing because we'll use Kahoot. but I need to, what of answers? Yes. I need to think before clicking the buttons because else we get questions in wrong answers, stuff like that. So I'm going to share the screen with the, first I'm going to turn off the sound because I hear the sound. There we go. I have a Kahoot, and this Kahoot will determine prize winners, stuff like that. So if you would like to have some form of prize or a goodie, come give it a try. Yeah, there's Jasper and MGB Hero. So yeah, the only thing I'm worried about is the delay. I know YouTube delays the stream a little bit, so let's see what's how it goes, and else we'll find another way to pick a winner, and we'll be fine. We have plenty of people. Ali is in the house again. I believe from Egypt, Ali. So welcome again. Ik ben gek. Peter is putting learning NRCG and welcome. I read on the Discord it's your first meetup, so welcome, welcome. Nice, nice, nice. Richard thinks that old people cannot answer questions. That is clear. I think he will be fine. Let's wait for Richard real quick. Yeah, Ali, hello. Good to have you again. Let's see. I'm thinking Richard is having a hard time connecting or... Yeah, there you are, Richard. Well done, well done. All right, so let's get this game on the road. Like I said, there's 10 questions. The theme of the question is our meetup, basically. So our Discord, our community. During my presentation, I have given a lot of hints as to the answers in the questions. So you might have thought like, oh, that's a strange thing to say during a presentation, and now you will go like, oh, right, now I know the answer. So good luck, everybody. May the best person win, I guess. Here we go. So the question is, what is Hack the Box new learning platform called? There we go. Yeah, most people had it right. It's called Academy. Let's see what is. Okay. Oh, the other one that was picked was Battleground. That's actually the gaming platform. And Rope is a very headache machine. And school is just a word. So well done. Let's see who is ahead. Peter Nuss, awesome. You've done very well. Carl is on your heels already. So let's go to the second question. In a previous meetup, we had Egress join. What is his real name? Yeah, Ian Austin is his real name. He is also presenting. He's giving us a walkthrough in the next meetup. So that's the hint I gave. Rami Malek actually plays Mr. Robot. So yeah, and let's see the other one, Egress. Well, that's not his real name. His parents did not call him Egress. So yeah, most people got it right. There's some people reporting a delay. Hopefully, it will catch up. So I'm talking a little bit before we go to the scoreboard. Let's see, Kite is doing really well. Peter Nuss, you're also doing really well. Good luck, everybody, with the next question. Yeah, I just said it. Yeah, Battlegrounds was the right one. Some people are reporting a very slow screen. We can give it a try in. Let's see if I can give you a few of the questions within Discord itself. No, I don't want this one. I want to share a screen. I want to share this one. Go live. Let's see if we can do it. I have no clue if it actually works. Fell asleep. There we go. I hope you all see the stream either on YouTube or within Discord now. So let's see who is on top of the board. Abdullah is picking up and Carl is on fire again. I wonder if Carl will be the person that is in the top 5 of every game that we ever hold. So let's take a look at the next question. Number 4, true or false? Yeah. Most everybody has that, right? That's the theme for tonight. So I'm just making sure that people on Discord. I also put the video there as well. So I'm going to assume it works. So let's look at the next question. Multi-select, so select more and then press the submit button. Who are moderators on our Discord? There's multiple choices. Yeah. Well done, well done. Most of you had it right. Levitating businessman, Rijn, he's not a moderator. Meneer OK is also not moderator. He could not be here today, Meneer OK. He's been at every of our meetups. Most of the time he says that he has a meeting someplace, but he always sticks around. Today he had a meeting that he could not miss, so he sends his best wishes. Yeah, very good. So top two are very close together. Let's see what the next question is. It's actually a poll, so no points to be gotten. But we're quite curious as to what your rank is on Hack the Box. Nice. Look at that. We have a very diverse group. We most are pro hacker and above. So well done. We have several noobs that have no or very little rank. Hacker and script kiddie. So nice. We see the lots of diversity in the group. When I click next, the next question will come up. And then here we go. What book series is our traditional reading? Yeah, it's Miffy. It is somewhat of a tradition. Today we will not have a Miffy reading. I had somebody who was going to do it, but he had to cancel. Um, Levitating Businessman says we should have a reading of a transcript of Mr. Robot. I don't think that will be such a good idea. Let's stick to Miffy. So yeah, let's see what the score is like. Yeah, the top ones are going well. POG4, well done, well done. Let's take a look at the next question. Number 8 out of 10. What date was our first meetup? Yeah, most people have it. Yeah, it is April. In March, I think I already said it like 3 times this evening. In March, we'll have our 1-year anniversary, which means that we have the full cycle of 12 months. That means that our first meeting was in April, and it was April 15th. So, yeah, almost a year already. So let's see what it does with the. Oh, POG, you were so close. Let's see. Last couple of questions. Here we go. A quiz. A very easy one to also have a technical part. What port number is SSH? Yeah, well done. Somebody probably thought like I'll click really quickly, but it's 22, of course. It was a question meant to get everybody on a yay. There is a remark by ESP Dead Beef says depends on what port you bind it on. True, but in general it's 22. So Peter and Carl are still going strong. Let's see, last question. Here we go. Number 10 out of 10 to celebrate. Gevulde cookie always says whoop, whoop. True or false? Yeah, well done. It is true. It is true. Whoop, whoop. But let's see what the score is like. Number 3, MGB Hero. And Carl is number 2. And number 1, Peter Nuss. Well done. And Ali and Wolfitz, you are runners up. So let's see. Who? Yeah, shame on everybody who has that wrong. Well, there's also new people here, Fill the Cookie, so they could not know this. But yeah, a whoop is a whoop and not a whop, right? Let's see. There's some people still here. Yeah. So yeah, Gevulde Cookie. You have some prizes to hand out, I believe. Blame the lag. Blame the lag. Well, yeah, I do think the lag should be blamed for stuff, and that would be very true. Let's see. Stop screen. And I wonder if Gevulde Cookie is still here. There's a whoop and there's a whoop. Yes! Whoop whoop! There you go. There you go. Yeah, we hear you. Yes, yes. I switched you on. I want. You forgot. Nice. Well, we have 3. Well, we have 3 VIP packages to give away, and then I need to look at who is eligible for that one. Next, there we go. Few full reports. Yeah, few reports, because we have something special to give away, or we think it's special. But let's see the first 3. There we have some VIP things to give away. I know Carl will say, "Well, I already have VIP, so you can give it to somebody else." But the other the winners were click Peter Nuss. He won, and MGB Hero. So MGB Hero, Peter Nuss, and Carl. And they're typing. Maybe they don't have a microphone. That's bad. That's bad. But MGB Hero. Oh wait, I should put my microphone on. I will mute myself. Yeah, there we are. Hello, Alex again.
So, in how long should we start the workshop?
Well, I was thinking we can move the workshop into Discord
Okay.
so that you can have direct communication with people that have questions and that are working on the exercise that you give them.
Yep. I
And
will. So we disconnect the live or
yeah, we'll disconnect
oh,
the YouTube stream. We've done the presentation, we've done the game. There's only the workshop part remaining, in which
yep.
people will actually do some work. We can do that in a voice chat on Discord and in the text chat that comes with it. And then for now, we'll just end the
Yeah.
broadcast of the live stream.
Yeah. Let me do a little bit of explaining of what we.
Yes, that's what I want to ask if you want to
Yeah.
explain it before you.
So the workshop will contain a couple of files. Let me go to it. It will contain the source code and the binary of two vulnerable programs. One is for a little bit more beginners. The second is for the little bit more advanced. But the thing is, both are as easily exploitable, but the vulnerability itself is a little bit harder to find in the second one. Both provide addresses to the buffer that you need to override. You don't have to deal with ASLR. You will see in the readme.txt command to disable ASLR on your system. You can do this temporarily, but just execute it as a root in your VM. And for the first program for the beginner, I provided an exploit too. It's an incomplete exploit, so you will have to modify the padding length and the return address pointer. And for the vuln 2, you will have to write the exploit by yourself, but it should be very, very similar in exploitation to the first one. And I will post the links on the Discord, and I'll see you there.
Yeah, I had to figure out how to remove you from the entire view. Yeah, so let's continue within the Discord. Thank you for preparing it. I'm looking forward
Yeah,
to
for sure.
actually giving it a try. And well, let's see how it goes.
Yep.
So yeah, as we already said, most people are now in Discord working on the workshop. We had the prize ceremony. It took some time to find the real Jasper in the bunch, but we figured it out, and he's having his prize. So we gave away 3 VIP passes and a month subscription to a Pro Lab of choice. So that means that the hackers can keep hacking. So I'm going to close the live stream now, as we're all in a workshop. Next month, December 16th, we'll have a walkthrough by Ian, the builder of Machine himself. So that should be good fun. See you there.